And now, after talking for 10 minutes, I pressed the correct button and the stream is live. I apologize greatly. Just imagine that I did a really nice start and I talked about these really important things and I went through and answered all the questions that are currently in the chat. Um, but I thought I had pressed the stream start button, but I obviously had not pressed the stream start button. I apologize for that. I assume that the first 10 minutes there just never happened. Um, am I online now? I really should have guessed when I said, is my mic working and stuff, and then no one said anything, and I just said, well, I'm going to assume it's working and I'll keep going. Okay, so I'm going to really, really quickly answer those questions, then get into the lecture. So, next week, I'm going to give two lectures. One of them is going to be very much more live stream than a lecture, where I'm going to do some code. And I'm not going to talk any theory, I'm just going to do code. And none of it is going to be anything new. It's going to be all stuff that I've taught previously. It feels really weird saying this again, except that the last 10 minutes when I was saying it, I was just talking to myself. Just talking at a camera which had its lights on and everything, but I hadn't pressed the publish button. Reese, my mic is working. Thank you very much. And Jet, yes, I've been answering all the questions to myself. Okay, so I think Masony had a question there asking what was going to be next week. So I've got one which is going to be a demo of all the code we've done so far. We'll see if we can squeeze all the code we've done so far into 2 hours. We won't be able to, but we'll try. And the other one is a talk on professionalism that I've given a few times before at CSE. Well, I've given it every time I've taken 1511, and it's a look at in the future. So the idea that you're eventually going to want to take your skills somewhere and do something with them. And so we talk a bit about, originally this talk when I first gave it was about how to get hired, how to work in a team, you know, how to fit into an ecosystem of a company and things like that. But as time's gone on, I've shifted the focus not just on how you want to get hired, but how are you going to stay happy in what you're doing and stay fulfilled with the work you're doing. I may have said this better about 5 minutes ago, but you know, I'm trying to go through quickly now because I've wasted the first 10 minutes. People are asking what's happening next week. There are no tutorials or labs next week. The weekly test that has been released now, well, there's one that's due at 8 p.m, so we've got an overlap, but the one that's been released now won't be due until week 7. So the possibility with what's known as flexibility week, which is week 6, is it is flexible. You can, if you want to, ignore the entire week, and you won't miss out on any accessible work, and you won't miss out on any deadlines. Granted, at the very end of the week, the assignment is due. So if you decide not to do any work that week, you probably want to work on the assignment a lot now before you go away or something like that. But I mean, there's been 2 weeks of the assignment, so I think if you're planning to go away week 6, you had kind of 2 weeks to work on it if you want to. I mean, you don't have to get 100% in the assignment, by the way. I think that's a fallacy that gets carried over from high school. Everyone tries to do all the stages in the assignment. It's not really what they're there for. That would be like trying to do all the challenge questions every week, which is nearly physically impossible. I mean, some people can do it, but I would never set that as the bar for what you need to be able to do to be a successful student. Okay. There was another question Alec was asking about clearing memory in the course. We are definitely going to talk about allocating and deallocating memory. We call it allocating and freeing memory. If I remember correctly, week 7, because I'm just about to teach you the final pieces of information that you need to start allocating and deallocating memory. So everything except for the actual act of doing it, I'm going to teach you this week, which is today, because today's the last lecture this week. Right. Andrew was asking about functions as pointers. Yes, there is a way that you can point to functions with pointers. We're not going to teach that in this course because we've got enough on our plate as it is. learning about pointers to memory. We're going to be using pointers to memory, like as someone who's worked as a programmer for a while. I don't have a very good understanding of function pointers, but I've got a pretty good understanding of memory pointers. And I think that'll give you a vague idea about how often they're used. Is you can, not always, but most of the time you can get away with not using function pointers. But not understanding memory pointers is something that would hold you back. Right. Okay. And then everyone's celebrating that I actually turned the stream on. Ooh. Wenkai's having some source file errors missing. Dean, you're saying it's working for you? We'll have to take that one offline and have a look at it. Okay. SK's asking about moving multiple files at once. You can, but selecting multiple files at once can be a little bit fiddly. In terms of, if I wanted to move multiple files, I would have to be able to name them. So usually when you do the mv command, you're going to have two file names, one where it's coming from and one where it's going to. Actually, I'm not sure if we even can, because usually if I was going to delete multiple file names, I would do something with a star to be able to select more than one, because the star is like any letters. Or I would grab an entire folder and I'd use the -R to recursively go through the folder and take everything. So that would be one way to move multiple things. You can definitely move a folder. Okay, I'm going to go on and we're going to start the lecture now that I have started it very badly previously. And we'll talk about what did we cover yesterday, because I didn't have a Wednesday. I don't know. I can't even remember what I did on Wednesday. I think they turned me off for the night and then they recharged me over Wednesday so that I could lecture again today. Robo-lecturer, beep boop. Anyway, so we talked about debugging. And we were talking about two different kinds of errors. And I was showing you some of the tricks and procedures you can go through to try to find those errors and then fix them in your code. So one of those error types was a syntax error, which is usually pretty easy to find because your code usually won't run unless unless the syntax is correct. So we can think of these as like grammar errors, like are your semicolons in the right place? Have you used the correct keywords? Have you spelt your variable names correctly? Or we think of them as the slightly more insidious, are your brackets not the right number of open and closing brackets? Have you accidentally forgotten to close a bracket somewhere, and so everything from a certain part onwards is contained in a loop? You know, little things like that that can cause some pretty big problems. And we looked at hunting them down. And then also, I think the things that you're going to spend more time trying to find, which is logical errors, which is, have you actually solved the problem that you were trying to solve, or have you solved a different problem by mistake? Have you, in the course of your programming, forgotten what the original purpose of the program is, and have made something that doesn't serve the original purpose of the program? That's one of these things we get where the looser we are with our specification is us saying specifically, that's why it's called a specification, specifically what we're going to do. So freefall is a good example of that. It specifically tells you how everything works, inputs and outputs, and ranges, and the size of things, and what everything means in exact detail. When we get given something like that, it's very easy for us to program. Sometimes we get given something where it's like, hey, you're a programmer, right? Can you do something that just does like a Space Invaders kind of game? And you say, yes, I technically can do something that does a Space Invaders game, but what do you actually want this for? You know, and then when we figure out what someone wants it for, what they need it for, and then we can say, okay, because you have that intention, we can write a specification that matches your intentions, and then we'll code something that exactly matches that specification. If we don't do that work, as programmers and engineers, we can end up in a situation where we get completely lost in what something's actually for. And that's a massive logical error, and all smaller logical errors are some version of that, of getting lost between the intention and the goal and what you physically coded. And at a lower level, it's kind of like, oh, I'm thinking I want the program to do this, and then I type some code in and it doesn't happen to be exactly correct. So we looked at ways to figure out exactly what your code is doing so that you can see whether it matches your intentions or not. Then we introduced characters, new variable type, which used letters and any other symbols, kind of like any key on the keyboard in a sense, including stuff like the space and the enter key. And I'm going to continue with them today, and we're going to expand them into strings, which is collections of letters. Andrew's asking what happens to chicken when I'm turned off. I'm not alone here. It's all right. My partner is here, and she can feed chicken if she needs to. Leon is asking if we have new weekly tests tonight. Yes, it's actually already been released, but this weekly test is a 2-weeker. So you don't have to finish it in 1 week because there are no due dates in week 6. I mean, like, the assignment's kind of a due date in week 6. It's the very end of week 6. But the weekly test won't actually be due until Thursday, week 7. So if you want to, and it's perfectly viable if you want to, you can completely ignore the weekly test that's just been released until after you finish the assignment. I mean, I would nearly go so far as to suggest that, because the weekly test that's due in week 7, you've got 4 days to do that after the assignment's due. That's more than enough time to do 1 hour's worth of work, whereas you might want to commit a lot of the time during your flexibility week to the assignment, because the assignments are worth a lot more marks than a single weekly test. Okay, what are we covering today? No, it says, what did we cover last lecture here? I actually edited the yesterday out this time. When I get all lectures in the morning and lectures 2 days in a row, I'm going to like enjoy it because I'll just be able to go back and say things the way I want to. Okay, we're going to continue with characters. We pretty much finished everything we were talking about characters on Tuesday, but we're going to continue with a little recap. And then we're going to talk about strings, which is words containing multiple characters. Since I've accidentally burnt the first 10 minutes of the lecture, we'll see how we go at squeezing everything in. I will probably not do the entire example for strings in the lecture because I know that I'm probably going to run out of time before I finish that one. But we'll go on to structs instead, because this is something that I want to leave you with before we go on holidays. I want to have at least shown you what structs are, but I wanted to finish our stuff on characters and strings first. Okay, so we were talking about characters in code, so this bit's a recap. And we had... This is a way of saying to our computer that we want to store not just the letter A. Me putting in quotes here is saying that letter A can be represented by its ASCII value, and if I'm storing it in an integer, that's what it's storing, its ASCII value. And we can find that out by printing out that integer as if it's a character or as if it's a number. If it's a character, it turns it back into its letter format. If it's a number, it says this is the ASCII value of this. And we've got the demo code for that from last week's lecture there if you want to see it. We've got a lot of helpful functions that we can use. A lot of these are in standard input-output, like getchar and putchar, and these will do. And we did some testing actually afterwards. If you want to look at what happened after the lecture, people will go, can we pick at this and see how it works? We saw that getchar and something like scanf%c were going to have nearly identical side effects in that they were both going to take a character and write it into a variable. The thing that was different for them is that there wasn't the side effects, but it was actually the function output of both of them was different. So scanf is going to say whether it did or didn't read a letter correctly in a different way than getchar is. Getchar is going to say things in a different way. So you can still use them nearly interchangeably though. So example here using getchar and putchar, I think we went through that. And we also looked at the idea of invisible characters, that new line is actually a character and it has an ASCII value. I think new line was 10, if I remember correctly. And stuff like space is a character. Space, if I remember correctly, was 32. So they actually have ASCII numbers, and so they can be seen as characters. And I guess that's one thing that you could consider as slightly different from some of the ways that we would use scanf and printf. Even printf can print characters in new lines, actually. Like, we've definitely been printing new lines. We've been doing lots of them. That was like very early on we explained what that was. But if we're reading things like a %d, we're going to ignore all the spaces in new lines. But if we're reading with %c or a get char, we're going to be able to pick up these characters. We talked a little bit about end of file as well, saying that there's no more input if we receive end of file. Get char is going to give us a -1, which is the define for end of file at that point. So we can figure out when we're not going to read any more characters like that. I think this is where we were up to, where we hadn't done any work with multiple characters yet. So let me hop in here to VLab. I'm going to go to last week's lectures and open the character demo. You may notice that I've stopped explaining to you absolutely everything that's happening in the terminal. If you're still worried about how things are working in the Linux terminal, hop into one of the help sessions and talk to someone about things there, because I think there's still questions on that, but I'm going to be holding your hand a little bit less on how to work in the Linux terminal now. As someone was saying before, you can actually control all the files and folders from in here if you want to. You want to have a slightly more familiar view of things. I would still suggest using the terminal for everything that you're going to do with compiling and testing and things like that, because that's kind of stuff that you do need to know still. Alright, so we had this, and we had the ability here to read multiple characters in a loop. So this is commented out, the previous examples. And here we have the ability to type in multiple characters, and we can press Ctrl-D to stop reading in characters. So we've got an integer, and then we get char into that integer. So that's going to give us a number, which is the number value of the character. And if it does read something that is not correct, like end of file, then it'll say, I'm not going to process this character. So basically, this integer is going to get characters read into it over and over again, using this while loop, and every time it reads a character that is a valid character, as in not end of file, it will print out which character it read, and it'll tell us what the ASCII code is. I mean, it's the same kind of thing that all these were doing. They were saying, okay, this is what I read, and this is its ASCII code. So let's compile this. Character demo. If I run char demo, I feel like char demo is like a Pokemon evolution. So now I can type in multiple characters, pressing Ctrl-D to stop. But since this is a loop and it will keep doing things, every time I actually send the characters to the computer, it will process them. So note that the loop isn't running yet. Not until we press enter does our input go in, because we can still, as the human, we could still edit our input if we want to. So it doesn't have to be confirmed until we press enter and it's actually sent to the program. So that sends to the program 5 characters. Instead of the 4 that I wrote, the 5th one's actually the enter key. So it says letter A is 97, letter B is 98, etc. One of the things that you will notice if you work with this a bit is that the letters that are sequential will actually have sequential number codes. So you can do stuff like plus and minus of letters. Just bear in mind that if you go off the end, so if you add 1 to Z, you don't really have a guarantee of where you're going from there. So it's not always advisable, but it can work. Then we have this line here, which is the interesting one, is that I read this character, and then somewhere around here there's a new line that's been written there instead of the character, because it wrote the character back that I gave it, and I gave it a new line at the end of here. It wrote it back as a new line, but it could also tell me what the ASCII code is for a new line, which is 10. So that's a bit interesting. And we can do stuff with numbers as well, and something to note, and we had a discussion about this after the lecture last time. We were talking about different numbered characters do not actually have the same ASCII code as their numerical value. So ASCII did not reserve the first 10 digits of its encoding for numbers because it used the first 10 digits for kind of system information in a sense. Like it's a whole bunch of electric typewriter stuff. If you look it up, it's quite interesting. And I'll do this other thing here where I press space a few times and press enter, and here we see that space actually has an ASCII code as well. So it's nice to know that all these little things can have different codes. In general, we're not going to worry too much about what the codes are. We're not going to try to memorize what these codes are. We're just going to know that characters are represented using numbers. And so any operations we can do on numbers, we can do on characters. Which means if I really want to, I can multiply characters together. I don't exactly know why you would want to do that, because they don't really have a relationship to each other that has any bearing on whatchamacallit, on multiplication. But there are other things that you might be able to do. Okay, I'm going to press Control D, which is going to end the input there. That's the Control D, and just ends the program because that's where we were at the end there. Okay. Couple of questions there. Dean is pointing out, yes, there is a help session after this if people want to go and talk to him specifically about things. He can help you with your assignments or any of the content that's troubling you at the moment, because, you know, we create more content as we go along through the course, and so the chances of you having trouble with the content get higher the more content we give you, basically. So help sessions are there to help you out. People are having a discussion, a lively and healthy discussion, about the different ways to style multiple words in a program. You'll notice that I've been jumping back and forth between snake case and camel case in my programming examples, just to show you that there's no particular reason why one or the other is necessarily superior. It's more of a subjective thing. And depending on where you go and what you work on, you will be sort of put into one of two ways of doing it. And I'm sure it's one of those things that, because it doesn't have an exact need that it's fulfilling, the snake case versus camel case thing, so it's quite trivial. So of course, for things that are very trivial, these are the things that people decide it's the hill they're gonna die on, and you must do one over the other. So if you want to, you can take part in those kind of sports. I call them sports because they're trivial. It's not a war, it's a sport, of fighting for one of these teams, knowing that you will never have a choice about which one you use once you start working professionally. Unless you join a startup as the lead coder and you get to dictate the style guide at the beginning. At that point will be the only time that you will actually be able to pick snake case or camel case. At pretty much any other time, you will just go in and ask what the project is currently using, and then you will use that. So that's why I love it as an argument, because even if you completely trounce someone and win the argument of camel case versus snake case, it makes no difference. You still won't get a choice. And Taylor's saying if I add 1 to Z, I'll get an open curly bracket. That's good, because I can never remember what comes directly after the letters in the in ASCII. There is one cool thing you can do, because all of the lowercase letters are in a certain section, and all the uppercase letters are in another section. And if you add a specific number to them, you can change something from uppercase to lowercase. That might actually be a tutorial and or lab question in week 7 when we come back and start doing them again. Obviously, week 7 is going to have a lot of character stuff in it. Yes, and I see there that the argument of camel versus snake is happening in full swing in the chat. Thank you, all of you. I'm going to continue lecturing so that I can just barrel over that potential issues. Well, at least people have figured out what the definitely wrong things to do are. Reverse camel case is wrong because everything looks like a constant. No case at all is very, very bad. I mean, that's like hashtags. Hashtags don't have camel case or snake case. And when they first appeared, all of us programmers were like, deal with this. You have all this ambiguity about what words are actually being said because you don't have separation between words. And we solved this problem years ago. But as if we could get enough control over hashtags to correct people on that one. That's going to be one of those things that we're just going to have to let go as a society. Luca has reverse snake case. My god, that looks like the hardest thing ever to use. So what Luca's come up with is underscores between every single letter except for the ones between words. Yes, we're going to move on from that. Okay, other things that we can do with characters that can come in handy. There is a library that you can use with characters, and it's called ctype.h, so character type. And that allows you to, like these functions here will allow you to ask questions about characters, and they will also allow you to convert characters to different things. This is only an example of what's there. There's way more there, but is alpha will be able to tell you whether the character is an alphabetical character or not. Is digit will tell you whether it's a numerical character or not. So these are pretty handy. If you want to, you can use these to skim through a big set of characters and look for the ones that are the right kind of data that you're trying to use. So you want to pull the numbers out and put them into an integer array or something like that. You could do that with isDigit. And you'd need to like scan through multiple digits until the digits end and go, okay, this is a chunk, and this is the thing that's going to become an integer. So what scanf with %d is doing for you most of the time. We can see if it's lower or uppercase with is lower and is upper, and we could convert between lower and uppercase. So a second ago I was saying, ooh, there's a magic number you can add or remove to ASCII codes to change them from upper to lowercase. You could actually just use this instead, and it'll probably work potentially with more safeguards than me saying add a magic number to something. Okay, coming on to new content that we're working on today. The inevitable continuation of learning a variable is what happens when we put this variable into a collection. So putting this variable into an array, for example, an array of characters is a string. So a string is a term that you're probably going to hear a bit. I've been sneaking it in through the term saying a string of characters when we're doing stuff like printf. Like so. This is a string of characters, which is simply multiple characters put together in a row in memory. I don't know if this is necessarily in memory. Oh, I guess it is in memory. Even temporary variables exist in memory. They tend to exist where your code is in memory rather than where your other variables are. But strings in C are arrays of characters. So we're already very well equipped to work with these because we've spent a fair bit of time working with arrays of numbers. So all I'm doing now is changing what we're storing in the array. There is one subtle difference, and this comes from the way that we use strings rather than anything really C specific about them. And it comes from two issues. So one is that arrays don't change size, and the other thing is that words generally do change size. So if I say, I would like to store a number, then I get an integer, and I get a big maximum, and I can use part of it. When I say I want to store a word, I can't necessarily tell C how many characters should be able to be stored in an array for a word. So if I can't say how many there's going to be, what I'm going to have to do, and I've showed examples of this as well, is maybe use an array that's arbitrarily large, but only use a portion of it. And so strings, this happens so often that they end up with a special way of dealing with this, which is the /0, which is known as the null terminator. So I always love that word because it's like this. It's a symbol which is actually a character, and all it's saying is that in this array of characters, once you read, if you're reading from left to right, once you read that character, everything afterwards doesn't count. Everything afterwards is not part of the string. Everything before it are the letters that we're going to use in the string. And to make ourselves sound really cool, we called it the null terminator. Yeah, I will terminate your strings. Yeah, okay. I don't think I'm a very good Arnold Schwarzenegger impression, but I just did that for fun. So what it does is it tells us when we're at the end of a particular string, which is not the end of the array, but it's the end of the word that we stored in that array. What do we got? I think Dean's answering questions there. Okay, good. So, how we start actually using strings in code is not super different from how we were doing things with integer arrays or double arrays. So for example here, I can have a character array. So this is pretty much the only time we use the type char, which is really interesting because I've introduced characters yesterday. Oh, I'm getting confused with my time differences. Not yesterday either. On Tuesday, when I looked at characters, I actually used, and we'll see it in here. Let's just get rid of those comments so we can see really closely. Note that this is a demo of using character variables, and there are no character variables in this. There's literally the word char, apart from the ones that's part of our variables, a part of our names of other variables, does not actually happen in this code. So funnily enough, I said I will give you a demo of characters, and I didn't use characters. I used integers for them the whole time. Because when we're working with single characters, chances are we're going to do something like a get char, and for us to get information out of the get char, we need an integer rather than a character. So when we're using single characters, we very rarely use the character variable type. Whereas when we're using strings of them, then yes, we will use the character variable type, because at no point are we going to want to put a -1 in this string anyway. So here at the top, I could do the same kind of thing that I've done with say integer arrays and things, but I could actually do this without a length here, and I can say create this variable, create this array, and each of these characters would be put into that array. This would include this null terminator, so we could put the null terminator in to say, okay, this thing finishes here. But there is a more convenient shorthand where we just use the double quotes, and this is going to be easy for you to use because you've been using them for ages with printf. So printf was actually creating temporary strings and then dumping them to screen. If we wanted to save those strings in memory with the double quotes, we could use them and create a character array, a string like this. Both of these would create the same kind of pattern in memory, where they would store the letters H, E, L, L, O. This would be storing their numerical ASCII values for these letters, but I just kept them as letters here. And they will also store one extra character, which is the null terminator. So the thing that we do have to remember a little bit is that every string in memory is always going to be one longer than we think it is, because there's always going to be one of these on the end. Chances are every string that we store in memory is going to be sitting in an array that's much bigger than it, because we'll have some kind of all-purpose array for storing a word, and then the different lengths of word that we put in there will all end in a null terminator, but it's rare that we'll actually use the entire array to store our string. So that's the way that we're going to start using them, and we're just going to be getting around the idea that the null terminator is always going to be part of what we're doing when we're using strings, and it's going to be determining for us exactly how long that string is. Get to the dropper. Okay, if we're going to do quotes, we have to do them all in our new reverse snake case. This will slow down chat. Weiwei's asking, we don't need to tell the size of the string. If we create it with content, like this, then we don't have to, because it will do the minimum size it needs. However, we can definitely create an array that's bigger than the strings we might need to use, and then put stuff in it afterwards. Reese is asking if null terminators are applied automatically. Null terminators will only be applied automatically if we use these double quote strings. In any other case, we have to do them ourselves. There's plenty of situations, though, where the null terminators will be automatic. So a lot of things like if we were to scanf for a string, we'd get a null terminator for free. I can't think of any other examples. If we have functions from the standard library that are going to output a character array that's usually written as character pointer, I think nearly every time we use those, we're going to get our null terminators for free on the end of things, but I can't be sure. And there's always going to be limits where it won't work. Oh, I should not have asked for the reverse snake case because now I can't read any of your comments. Oh well, that's how the lecturer doesn't pay attention to his class anymore. Ask the class to write things out in a way that I don't understand. Okay, reading and writing strings, there are some library functions that are pretty useful for this. fgets is one of them. I think this stands for, I can't remember what the F stands for, but get string. Basically, it's a shortening of get string. So what we will do is we'll give this function an array. That's the piece of memory we want this function to write information into. We will give it the maximum length of letters that it will read, and we'll tell it which stream to get things from. For the moment, we have only one stream. The only stream we're using is called standard in, standard input, and that's typing into the terminal. The further you go in computing, you will learn to open other streams. So you can open a stream which is a file. So you can say, this file from my hard drive is a stream, and then I will read from it as if someone was typing in there. And further on you go into computing, you can say, this network port is a stream, and any information that I receive on the network port, I will write into this array, right? So for the moment, we're going to consider the stream to just be what's in the terminal, because all that other stuff is much more complicated. And we'll get there the deeper you go into computer science. But for now, we're going to work with one stream so we get an idea of how these things work. So fgets, writing into an array a certain number of letters. This can be a maximum number of letters, so you don't have to read all of these letters. So you will receive something that is up to length number of characters. So you can do that to make sure that when you're reading in from the stream, you don't go over the size of array that you have. And so what we can do here is we can type a whole line of information, and one fgets call will grab the entire line of information and throw it into an array. So that's as opposed to scanf, and scanf would want to grab individual pieces. It'll try to basically convert them into function type, not function types, variable types. Like %d is saying, I'm going to ignore anything except for numbers, and I'm trying to grab numbers, convert them into integers, and use them. fget says, no, I'm just going to grab everything. I don't care what it is, I'm grabbing a whole line of information. And if we want to, we can also use the opposite of fgets, which is fputs. Fputs takes an array and a stream, and this time instead of the standard in stream, we say the standard out stream. And this is the same way of if we did any other stream, if we had other streams, we can reverse the direction we're going in it. And fputs says, I'm going to take whatever is in that array, and I'm going to write it out to the terminal. So this is very similar to me trying to do something with printf and print off an entire line. But I can do this with this function by just saying, all right, I don't care about making it. I'm not going to use the quotes. I'm not going to use the format strings to add variables into it or anything. I don't need any of that capability. I just want you to dump this array directly to the terminal, and it's going to be an array of characters. If it's not an array of characters, we won't be able to do it. But if it's an array of characters, then every character is like a key that can be pressed, and so all of that can be sent to the terminal, and fputs will do that. So both fgets and fputs are in our standard input-output library. So they've actually been waiting there in that library the whole time we've been working on COMP1511. We just haven't introduced you to it because it really hasn't been necessary for you to use it up until now. Dean's answering some question there. Ha! The reverse camel case thing has disappeared. No, it hasn't. Okay. Oh, we are reverse camel case pig Latin now? Okay, I'm just going to keep lecturing because I feel like the lecturing is more important now. Okay, the string library has a whole bunch of functions that could be handy. So it is called string.h. This is not everything that's in there. That's why I put and more at the end. But we can do strlen, and that will return an integer saying how long the string is, and this won't include the null terminator. It'll say how many valid characters are in the string. Strcopy and strncopy do reasonably similar things. They'll copy the contents of one string into another, which is kind of handy because up until now, if we wanted to duplicate an array, we didn't really have a function for it. We were always looping through with integers to do it. But if you're doing it with strings, we have some functions to do it. The reason behind this is we very rarely use characters on their own. As humans, the idea that we would use letters as individual things is not nearly as strong as the idea that we use words as individual objects. So while we're treating strings as the entire conceptual object, we've got some functions that allow us to do it more easily. String cat allows you to add one string onto the end of another. Struct. I apologize for all the names of these. You can see that they were trying to keep them all within 8 characters, so it's super old school. For us, it's a matter of just memorizing these things instead, or knowing that there's always a reference to everything that's in the string library they can use. So you can compare strings as well. You can find characters within strings. So there's a lot of capability here, and it's worth looking up the string library for when you're playing around with these, because chances are there's things that you could do that have already been implemented. In our lab exercises and second assignment, we're going to sometimes allow you to use a string library and sometimes not. It depends what we're trying to teach you. If we're trying to get you to go through the problem-solving process for a particular thing and it's already solved in the library, we might say, hey, don't use the library for this one because this is really useful if you step through the process. At other times, it'll be specifically use the library for this one because we want to show you how to use the library. So we'll swing back and forth depending on what we want to teach you. Okay. So, today, we are, in fact, in 10 minutes, in terms of lecture content, we'll be exactly halfway through COMP1511, because there's 18 lectures, and we're halfway through lecture 10. Oh, actually, no, it would have been between lecture 9 and 10. But anyway, I just wanted to put this heading on here. So, whoa, we're halfway there. If anyone doesn't know that song, especially because my rendition of it was probably not that great. I'm quoting the greatest karaoke song of all time, which is Living on a Prayer by Bon Jovi. This song has probably been sung drunk more than it's been sung sober in the history of its existence. But we're going to change that today because we're going to sing it. No, we're not. We're not going to sing it. But we're halfway through COMP1511. So what I'm going to do for the string example today is I'm going to chain together a whole bunch of the stuff we've used in the first half of the course, and we're going to do some stuff with strings today. And so we're going to do a word game, and what it's going to do is it's going to use a bunch of the things that are involved in strings and stuff, but in using strings, it's also going to use arrays, and it's going to use testing of variables, it's going to use while loops and if statements and things like that. So when you think about it, this is going to culminate everything that we've done so far in COMP1511. So, it's a word game, and here is my specification of exactly what it will do. It will read in a string from the user. So I've already given you some ideas today about how we could read in a whole string from the user. It will then read another string from the user and tell us how many letters in the second string appeared in the first string. So that means we need to go through and see if letters match between the two. So I can already think that in order to see if letters match between two strings, I'm going to have to loop through both of them. Right? And this might be a reasonably complex loop, because I may have to loop through the entire of one of the strings for every letter in the other string. So I'm thinking of a loop within a loop. This is my thought process for solving this. I actually intentionally didn't look at this recently, so I didn't look at it yesterday when I was going through everything. Just to make sure that what I was doing, I would actually talk through the problem solving process. And it's going to use a bunch of these little things. So it's a pretty simple game, but we are going to have to break it down into parts to be able to solve this. Let's see how we're going. Okay, Living on a Prayer has struck a chord with the student body. That's great. Priya saying like common elements.c. Yes. Was common elements one of the lab exercises? I think it was an integer lab exercise, right? And so now we're going to do this with characters. Oh, Echoic is asking, is there anything stopping you from having a 2D array of characters instead of ints, and then using the character version of numbers to do the things in the assignment? You could do that, and I don't think there's any reason why that wouldn't work. You just have to convert it back into numbers for output. Actually, you don't have to convert it back into numbers. The output's in characters anyway. Any kind of printf that's doing %d and putting a variable in is converting it into its character and then outputting it to the terminal. In fact, what you could be doing by doing that is removing a whole lot of the work that the program has to do to convert back and forth between numbers and characters. That could be a stroke of brilliance. It could make the entire assignment harder for you because you have to reprogram the stuff that we did. But you could do it. Make sure you test it thoroughly if you are going to do that, because you are taking on more work there. But it's interesting, though. I'm not against it. Okay, so the word game, let's break this down into the easy bits first and see how we're going to do things. So to begin with, we will read in a line of characters. And instead of reading in a second line of characters and seeing whether it's there, let's read in just a single character and see whether it's in the line or not. This should be an easier problem we can start with, and then we can see if our input and output is working before we continue. So let's read in a line of characters. So I'm going to start a new program here. I'll get rid of my character demo, and I'm going to make a directory for lecture 10, which is today. Go to lecture 10. There's nothing in here at the moment. I'm going to call this word game. Okay, I'm going to switch today. Wordgame.c. Taking a string from standard input, take another string from standard input, output a string which is, I don't know if we're outputting a string or not, I can't remember what the spec said. Tells how many of the letters from the second appear in the first. Okay, so we're not going to output a string. Output how many letters from the second string appear in the first. Okay, cool. I don't think this is going to be stupendously hard, but I still want to build this up in pieces. So, assuming all of this input and output are strings, I'm going to need standard input output. I think that's a good assumption to make. And I've got my main, and now I'm ready to go. One thing that I'm going to think of first is, if I'm going to take input from the user, I want to think about what is my line size of how many characters, what the maximum number of characters I'm going to take as standard input. So I'm going to want to define this so I can change this across the whole program if I want to. And I'm going to call it max length. What did I call it here? Max line length. Max line length might actually be a little bit more correct. It's a bit long, but I'll get away with it. I could say 80 characters, or I could play it safe and say 1,000 characters. It's not hugely different either way, because even if it was 1,000 characters, that's still only going to use up like 1 kilobyte of memory, and if you know how big the memory is in your computer, we're talking gigabytes of memory. It's not too bad if we use 1 kilobyte. It's several orders of magnitudes smaller than what could be used. So if the main array I'm using for this is huge, I just can't help it. As a programmer, it's going to be 1024. So let's say 1024. It's highly unlikely that someone's going to type in 1,024 characters just to test this code or use it. So I think that's safe as how big my line is going to be. Then I'm going to make my character array for it, and I'm going to use fgets to read in that information. So making my character array, and so someone was asking in chat before, about whether we set the length of the character array when we create it. It's just like any other array, so we can set its length. So the examples I showed in the slides were if we were going to initialize it immediately and it was going to get its length from the data that we were putting into it. If we want to give it a fixed length, like this max line length, we would declare it the same way that we would declare a normal array, where in here we would say its length. So I'm going to say max line length. I just use my autocomplete there. To say this is the size of the array that's going to store the line that gets typed in. And then we're going to say fgets, and fgets is going to take certain inputs. If I'm unsure about what inputs fgets takes, because it's a library function, right? So I can't see it. I need to look it up if I want to see what it can do. I can look up the manual. Fgets, it's in standard input output. There's some information here. This is the one I'm looking for because this is one that's spelt the same way I'm doing. First thing, a character pointer. So remember when I was saying that pointers and arrays are roughly equivalent? I can give an array to this input, even though here it says character pointer, because an array as input is functionally identical, so identical to the function, as me giving a pointer to the first element in the array. And then I say size, which is the maximum number of letters that I'm going to take in, and then I say which stream it's going in on. So the first thing is the array, and that's fine because I know I made the array originally, so that's line. The second thing is the maximum number of characters that could be read in, and that's going to be this max line length. I don't know if I want to be a little careful here though, because the max line length is not the number of characters that this array can store. So if this array is the size max line length, it means that it can store max line length characters if we don't have a null terminator. If we don't have a null terminator, it is not a valid string, so it's a little bit dangerous. So what I might actually say is, you can read max line length -1 characters. So if you do get someone that wants to type in 1024 characters, we still need space in this array for that null terminator. Leaving space in the array for the null terminator. Okay, that comment is way too far over. I'm just going to put it here. So that's why the max line length -1 is there. Sometimes when I do something weird, because this could look weird, if someone's not used to reading this, they could look at that and go, not sure about that, then the comment's there to let people know. It's reading that in from standard input, so that's the user typing things in. Oh, Dean's reminding me that fgets will subtract 1 for me, so I didn't need to do that. Thanks, Dean. Oh well. I got to explain something. I was wondering why that wasn't in my... See, past Mark had remembered this, but present Mark forgot. Okay. Alec is asking, how do I get the line to come up on gedit? Oh, this one? I can't remember. It could be in 1511 setup. If you run 1511 setup in the terminal, it sets up all of the gedit defaults, which is going to do stuff like that. Oh, or is it maximizing the window? I'm not sure. I'm going to let you figure that one out, because I've got code I've got to write here to begin with. All right. So fgets will do this, and then we could read in a single character. What I might do before we get char is I'm just going to do simple fputs here, just so that we can see whether our line reading is working or not. So fputs, going to put fputs in here, is going to take a string first and then the stream. So string first, then the stream of standard output, and this is going to write it to the screen. I'm just going to run this to make sure that it works. Okay, so save this, quit out of this, and DCC word game. and then we'll run this. Oops. Word game. And we'll type in a random sequence of letters, and it should give them back to me. So, Johnny used to work on the docks. There we go. Johnny used to work on the docks. So, I'm laughing at my own jokes here, because usually when I get to tell this joke, the audience is there in the lecture theatre and they laugh with me. This is the first line of the song Living on a Prayer, so you can already tell that the theme of what I'm going to what I'm going to be doing in this word game is going to be something to do with living on a prayer. Okay. Okay, so people are talking about the line, and Dean's helping out there. Okay, let's take a break now, because we're at 5:05, and I got pretty close to being on time now, because I was also going to read in getchar to take a single characters and check if they were in the string, but we'll do that after the break. But we're going to take a break now. So I want to say a couple of things, because we're halfway through COMP1511. But in terms of, like, you know, like, they call Wednesday a hump day, which is like halfway through the week, and it's the day you got to get through to be able to seeing the hope at the end of the tunnel. And so I feel like halfway through term 2, which is halfway through the year, can be one of the roughest times of the year. And I feel like this is the time where people get the most tired. And I think being tired means that it's easy when you're tired, it's easy to forget why you're doing things. You know, you forget why you want to do something, and you forget what it is you're aiming towards. And so I just wanted to send a little message out to everyone that when you get tired, and it's not always going to be right now. Some people get tired at different times. But I know that for me, I'm tired right now, because I know that we're halfway through the year, but then half of the year is still yet to come. We're pretty far away from having a kind of a big break. We do have a break next week, but I don't think I'm working any less next week. I'm going to be doing a bunch of lecturing anyway. In fact, I'm doing 3 lectures next week instead of 2, so it's nearly more. But I just want to remind everyone that you don't have to reach your goals. So one of the things about trying to get where we want to be is we can get impatient to rush to the goal. And getting impatient is one of the things that can kind of cost you. In a sense, it'll make you more tired than if you're just sort of happy to be consistently working towards things. So no matter how far away your goals are, or how hard it's going to be to get there, just making a step towards your goal is okay. Especially when you're tired. You don't want to stop entirely. I mean, sometimes you do. Sometimes you definitely need to take a break. And I think Flexibility Week's not a bad time to take a break, although maybe you're going to use Flexibility Week to do the assignment, up to you. But even while you're doing the assignment, you can take breaks in between. You know, you take an hour off or something like that, or you take a few hours and spend some time with some friends, because we can do that now, which is really nice, as long as you keep some social distance, you know. So I think you can continue moving towards your goals, but keep in mind that you want to arrive at your goals in life. You want to arrive at them intact, which means you don't burn yourself out in order to get where you're going. And so I just want to remind everyone of that, because we're in the hump in the middle of the course, and a lot of stuff has been quite hard to do up to this point. The continuation of the course is still going to be hard to do. So your aim at the end, you know, to pass the course, or if you're aiming for a particular sort of marks of the course or anything like that, take little steps towards it. The bigger jumps you try to make, the riskier things are, and the harder it is for you. So I just wanted people to think about that a little bit. Okay, we're going to go on break. I am going to flick over to the Be Right Back slide, and I'm going to go and look for a certain little furball and see if she wants to come and be fed in this room. So we'll see how we go. And everyone's saying they're waiting for chicken. Wait, James is saying it's not Johnny. Did I just get the lyrics wrong? That'd be pretty funny. I'm not even sure. Okay, I'll be right back. Alright. Alright, let's got our camera here. You can hear somebody asking for food. Okay. We're gonna do this at ground level this time. Okay, so here's the food. And there's your little friend. Move that back a bit. You can see more of them. Chicken loves the food. Full HP now. Oh, are we done? There's a couple more in there. Okay. Back up here again. Just give me a second. I will be right back. Okay, I'm back. Just had to put chicken's bowl away. So there you go. There's a slightly different chicken feeding stream today. This was the extreme close-up chicken feeding. Bit of a mukbang this time because we're actually like getting to hear everything that she's eating. Sorry, I was just printing something off and I think it's still going. It is. Oh well, I'll deal with that in a second. I'm glad everyone loves chicken. Okay, so continuing on with the code that we're writing. We were looking at a way that we can take input characters. So what we might do is we can actually run a loop that's going to continue taking input characters until we get an end of file. So this is really similar to the loop that we looked at on Tuesday. Actually, no, we didn't look at it on Tuesday. We had looked at it at the start of this lecture. So it's just taking characters one at a time. And each time we take a character, we grab another character. So it's a simple loop, but we will stop looping anytime we hit an end of input, which is the EOF here. So we're going to use this here in our code. So I might comment out the fputs there because we're not going to need that for the moment. And I'm going to say, I think I'll call it the input character. I'm going to initialize it as 0. I don't really need to initialize it but it should be okay. Oh, I should point out one thing. Someone was asking me about the initialization of this line. The line has not been initialized at this point, but fgets, when it uses it, is going to write into that memory whether it's been initialized or not. So I don't really care whether this memory has been used or not. However much of it we use is going to get characters, and then it's going to get a null terminator, which means there is going to be uninitialized data later in the array, but fgets should initialize it up to that point. I can't remember whether fgets does this or not, but fgets might, because there are certain things that will work on strings where what they will do is they'll fill all the rest of it with null terminators. So if you accidentally go beyond the null terminator, you'll find a point where it just goes, no, there's no string here, so it's okay. I don't know if fgets does that or not. I think for efficiency's sake, it probably doesn't. It probably just puts one null terminator where the character's finished. Oh, people are talking about boxes. Yes, Dean's saying that he couldn't do boxes when he was a student. I think that's also the point where the weekly tests are sort of showing you that not everyone has to complete everything. I think that's one thing that that we get to, that everyone tries to get full marks in everything. And I know chasing marks is what students do. And that's fine, because I run really fast, so you can't catch me. Get it? Chasing marks. Anyway, don't worry if you can't do everything. Not everything in this course is needed to be able to pass this course. Not everything in this course is needed to be a successful programmer later in life. So, it's not... I could say that all I want. I could always keep saying that things aren't a big deal, but I know people aren't always going to listen. Yeah. And also we opened up the use of arrays with boxes, so you don't have to do it the same way you were working on stuff like hollow triangle or spiral or anything like that. It doesn't have to be just output. You can set up the two-dimensional array and you can actually draw the boxes. Anyway. Oops. It's not due yet, is it? I've released the next one and I started spoilering the old one. I apologize. I'm going to stop that now. Okay, so let's take looping input, and we've got some of the code here. We're going to loop. So the first thing that we're going to do is take 1. So the reason I'm doing this is calling getChar once first allows me to test the output of getChar to see whether it's worth continuing or not. So if I want to test whether the character I took in is a valid character I'm going to continue, I need to have written something into input character to begin with. So I do need to read something to be able to find this out. If what I read is end of file, like there was just no input at all, then that's fine, the while loop will never run. So I'm going to say that the only time the while loop is going to run is if I don't receive end of file. If I received end of file, it means that the while loop is not going to run, which means I didn't receive a valid letter. And then this is kind of like my I++. This is like one of the few times I'm going to show you a loop that's different from the loops that we've been doing. So, I mean, although if you consider about it, if you look at it really formally, you could say this is just a sentinel value loop, because it keeps going until this changes, and then once it changes it says I'm not going to do that anymore. So here we have input character is equal to getChar. So what this means is I take a character in, if it's valid I do something with it. There's nothing in here yet, but I will do something with it. Then I get the next character and I go back up here. If the next character is valid, then I do something with it, right? Okay, so that works pretty well. I can use this to take in input. The next thing that I want to do, for each of these characters, I want to find out if they are in the string. So what I can do is I can write a function that says, is this character in this string? And we've done this kind of loop before. So if I said to you, if I give you one integer and I want you to find out whether that integer is in this array of integers, I'm pretty sure that you can do that now. So we've been working long enough with loops and arrays that you can probably do that. This is the same kind of thing, and the code here is going to be nearly identical. Find out if this character is in this line. It's just a different variable type. The only subtlety is we have the maximum length, but since we don't have the length of the word itself, we're just going to go up until we find a null terminator. So that's the only subtlety that's going on there. I might actually put my defines after my includes. So this is where I include code from other people, and then this is more pertaining to my stuff, so that's why I order them like that. Not super important which way you order these. And then my functions are even closer to my own code. This is how I lay it. This is how I remember how I lay things out. Things that are further away from me and things that are closer to me. So I'm going to make this an integer function because I need it to tell me whether it found something in the string or not. So test character is going to say yes or no for whether the character is in the string or not. So I'm not going to use a character because I know that's going to be in int. Ooh, it's a character. Actually, I could accept that as a character. Let's do it as a character. And I would like a character array. Oh, okay. I'm just looking at past mark and what I did there. We could do it as a pointer as well. So this is saying, give me a pointer to the start of the array, which is the array itself. And I take that function, some white space. It's a little easier to see if I do that. And then I'm going to explain this function to myself before I start writing it. Makes it easier both for me and for someone else using it. Loop through the string line and return 1 if C is in line, return 0 if C is not in line. Okay. Sometimes I like comments like this. I just make them super clear, and it says exactly what this function is going to do. So if I'm going to loop through line, I'm going to need an iterator integer, so something that's going to go through all the indexes in line. I'm going to need a while loop. The while loop is going to be moving the I. I need I to stay within the bounds of the array, and there's two ways that we know whether the data that we're using is finished or not. So one of them is the bounds of the whole array, and the other is the bounds of the string. So I don't want to go over the end of the string either. So I'm going to say if I is not equal to the character of the null terminator, then we're going to read. So we're going to keep looping until we hit the null terminator, and if we hit the null terminator, then we stop. So I'm going to say keep looping through all the characters until we hit the null terminator, and we'll stop if we hit the null terminator. So I'm going to say if it's not the null terminator, we can keep going. And if I remains less than the maximum line length, we can also keep going. So there's two things we don't want to do. We don't want to go off the end of the word or the line. We also don't want to go off the end of the array. There's a tiny outside chance that someone makes the line exactly 1024 length. But I think, as Dean was pointing out, that fgets would have stopped us from doing that anyway. It was always going to have a null terminator at max line length. Either way, I'm going to check both of those things, just in case. I'm expecting this one to be the case that stops us most of the time, because I'm expecting most of the time we're not going to type in that many thousand characters, right? So this is going to get us through the whole lot. And then we're going to say, I'm probably going to want to track whether we've found the character. So found character equals 0. I'm going to start this one at 0 to say that no, I have not found the character. And that's fairly obvious because if I haven't looked for the character yet, I haven't found the character. And in here, I'm going to set whether I find the character or not. So I'm going to put an if statement in here, and I'm going to say if the character that I'm currently looking at in the line is the same character as the one that I was given as input, then I'm going to say that I found the character. So if I find the character, it's going to it's going to say that we found it. Oh, you know what we might actually do? Yeah, that's what I thought we might do. Let's future-proof this against the possibility that we might want to do more with this function than what it is. Loop through the string line, and instead of returning a 1 or a 0, return how many times that character appears in line. I'm going to name these properly. How many times C appears in line? So character C appears in line. So instead of found character, I'm going to say this is a count of how many times it's seen it. So now what we're getting is something that's more powerful. We have a function that we could use for other things later if we want to count multiple times. So I'm going to use a plus plus here. Oops. Going to need this to be the new name. So this is still going to work as a true false, because if it never finds it... Oh, hello. Are you supervising? Someone's supervising. You can just see the back of it there. It's a very grumpy supervisor. If we never find it, we still get a 0. And if we do find it, we will get a number other than 0. So this is still going to work if we use it in a true-false situation, but it's going to give us more information in case we need it, so they can count the number of characters. So once we get to this point, we can say return the character count, and it will tell us how many times it's been there. So this is going to be have checked I characters. And then when we finish the loop, which we don't know exactly where I is at the end of the loop. But we do know that at that point, every time we saw that the characters matched, we added 1 to our count. So now we have a function that's going to tell us exactly how many times we saw a character. Let's put this in here so that we can test it. So I'm going to make an integer. I'm going to call it count. Maybe I do want to call this one the same name, even though it's not related, because they're in their own sets of curly brackets. They're completely separate. They don't talk to each other. But the name of the variable makes sense to me here as well. And I'm going to do test this character that I've just taken as input. So input character. This is potentially dangerous because this is taking in a character and I'm giving it an integer. So I'm not sure whether the DCC is going to give us a warning here or not, or it's going to respect the fact that we know that because we called getChar on this and we checked for invalid input, that we know that the value in input char is something that is also usable as a character. We'll see. We may still get a warning about this, but we'll see how it goes. So this will output, if we give it the line and that individual character, this will put into character count how many times it saw that. And then I'm going to do a printf here that says I found the character %C this many times. So the character is going to be input character, and the number of times is the character count. Okay, so we can test this now and see whether our function is working or not, because we've done this function. Reasonably simple function, right? It's a single loop through. The only things you need to think about are it stops when it sees a certain character, or it stops when it reaches the end of its array. Most of the time, it's just going to stop the first time it sees a null terminator. So, I'm going to save that and compile. Okay, so the integers and characters are interchangeable often enough that DCC is not too unhappy with us saying, I can give an integer to a character input. And what it's going to do there is it's going to say, this is up to you. If you give me an integer that is too big for my character, it's going to overflow. It's still going to be an integer, but it's probably just going to overflow and get a different value. So maybe it's okay with that. So we're trusting this because we've set up our code specifically to make sure that this number that we give here is definitely going to be a character. There's no way that we can run getChar, check for end of file, and not have a valid character in here. So hopefully this is going to work fine. All right, let's run this, see how it goes. Now, oh wait, what's everyone saying here? There was an error. Everyone's saying, do you mean C is not equal to null terminator? Wait, where are we? Oh! That's pretty funny. That's funny because I had that highlighted and everyone's like, he's behind you! I didn't even do that on purpose. And the funny thing about this is I think this while loop never would have run because I think the ASCII value for null terminator is 0. So this would just never have run it and I wouldn't have noticed until I tested it. So this is a classic logical error. I've written perfectly valid C code because I'm testing an integer against a number value, so you can test them. What I really wanted to do was what's in the line at that point. Is the character that I'm currently looking at, which is line I, is that one equal to null terminator, in which case we stop. Okay, thank you for catching that. This is not going to run anything in particular. I'm just going to Control-C to exit that. And we're going to compile that again and run it. So let me see what else everyone was saying. Someone said, how old is Chicken? Chicken is 9 years old. Aren't you? Yes. And Dean caught it as well. It's like, Mark, what are you doing? Yeah, and everyone's like, it's behind you. Yeah. Someone donates so that he looks at chat. I'm glad I don't have donations. That'll be really funny because then I'd start making mistakes just so you would donate. Okay. And everyone was like, you might notice it when he tests it. Fate is sealed. This is really funny. People are disappointed I didn't test it. It would have been interesting for us to test, actually. Okay. So we had Johnny used to work on the docks. I'm not even sure if that was the right line. I mean, like, as I said, it's a drunk karaoke song, so every time I've sung it, I've probably sung the wrong lyrics, and everyone gets the lyrics wrong anyway, so we're going to keep going. And the next line is, if I remember correctly, Union's been on strike. He's down on his luck. Oops. Down on his luck. Okay, so at this point, I'm assuming that that line of characters is here in line, and we're now in this loop where if I put a character in, it's going to test if it's there or not. So I see some S's there, so let's test the S. I found the character S 4 times. Ha! Great, how cool is this? I found the character something 1 times. So let's look at the S 4 times. 1, 2, 3, 4. So that's correct. I think my function's working correctly. The other funny thing about my function is it's a loop doing getChar. And as we've seen before, the enter key is a character. So we can actually test how many times the enter key is in this string here. And it turns out the character is in that string once. Because when I typed this in, I pressed enter at the end of it, and all of that went into the fget. So fgets is picking up the enter. And so the Union's been on strike, I'm down on my luck. He's down on his luck. S is in there 4 times. So I think that my my function is working correctly. It's finding characters, but I do have this interesting side effect that since the new line character is in every line I could possibly enter here, it might be screwing with my calculations a little bit. So I might end up seeing the new line more times than I want to. But we'll see how we go with that. All right, I'm going to press Control-D, which should end the input there. And so my program finishes nicely, like that. Oh my god, it's Tommy! It's Tommy, not Johnny. Oh, wow. You're right. It's Tommy and Gina. Yeah, because they're the characters in other songs anyway. Let's just pretend I'm not even drunk. Maybe if I get really drunk, I'll be able to remember what the words to the song are, because that puts me actually in the state of mind that I've been most of the time. Yeah. And everyone else says they're also down on their luck. I apologize to anyone who doesn't know this song, because there's a bunch of us having a conversation about a particular song here. Especially anyone who's not necessarily part of like sort of like general English speaking culture. Is that take the famous song that everyone sings all the time in your particular culture, but especially the one that people sing when they're just partying and they don't remember half of the lyrics. Exhibit A, they don't remember half of the lyrics, except everyone jumps in for the chorus. This is that kind of song. And it's probably a staple of karaoke at the Regent Hotel, which is the closest pub to UNSW. So, anyway. Oh wow, that's a lot of requests for a drunk stream. That's probably not going to happen, by the way. I do want to maintain a certain level of professionalism. I know that a level of professionalism at a certain level is too much, and it hinders people's learning. But there's a level of professionalism that is too low, and that also hinders people's learning. So I'm gonna stay at a balanced level. A friend of mine used to run the karaoke at the Reg. And this is what happens when like people like just after being students, we get all these jobs in the local area before we can get our careers going. Okay, back to code. We're in a good place now, because now we can go through these characters that we've picked up, and for each one of these characters we can find out whether it's been in the line and how many times. So we know that this test character function is reasonably likely to be working, and we know that we can test things in the line. We haven't yet expanded this to do multiple characters in the line. So if we wanted to, what we would then do is we would do fgets again, and we would loop through that instead of looping through individual characters, and then we check each of those, and then we could do a count then. So that kind of thing we could definitely do. I might not do it now, because I have other things that I want to talk to you about. What I'll do, okay, what I'm going to do is I'm going to save the rest of the example for after the lecture, if anyone wants to stick around after the lecture, because there's actual content that I want to go through now, which is structs. So we're going to talk about structs first, and then we'll come back to this content afterwards, if necessary. Oh, Celine has a song. I don't know the song, but hopefully that's the Chinese song. So the only one I know is like, oh man, a friend of mine sang it to his wife at their wedding. It's that really sappy Chinese love song that gets sung all the time. That was the one that I was thinking of when I was thinking of what that might be in China. And I know that in France it's Champs-Élysées. It's this like incredibly tacky, unnecessarily patriotic French song. And America's obviously this like is Living on a Prayer as well. I'm pretty sure they would be like down with that. I think Australia, if you want to find one that's even hilariously dodgy, you would just take anything by John Farnham, like You're the Voice or something like that, and then you're doing a deep dive into Australian culture, which I totally understand. Anyone not from Australia knows nothing about John Farnham, and that's totally fine. You're not missing much. But all of us seem to know the lyrics to those songs anyway. Yeah. So everyone's yeah. Oh, and also Cantonese. So Terry's going for Cantonese there. Anything by Jay Chow, right? So, oh, Charles is saying Boys Line. Okay. Before we devolve further into this, I'm going to continue my lecture on structs, because there's more stuff here, but we'll come back to it if we get time. All right. Ooh, there's a lot more stuff there. Okay, that's the completion of that. Okay, now we're going to talk about structs. Oh, Terry, I apologize. Jay Chow is Taiwanese, which means he's not Cantopop at all. Who's Cantopop? I don't even know. I don't know Cantopop. I'm about to prove that I know a little bit of K-pop, though, because the example in this is K-pop. Anyway, another variable type. Structs are one of the most interesting variable types, because instead of being a type themselves of a variable, They're actually a custom variable that's made up of other variables. Now, up until now, we have had variables that are made up of other variables, which are arrays, collections of identical variables. Structs are collections of variables that are not identical, which is why I have a picture of a bento box here. So a bento box is a piece of memory. Just roll with me for this one, all right? A bento box is a piece of memory that has lots of different ingredients in it. As in, I can put some integers in it, I can put some strings in it, I can put an array of other stuff in it, I can put structs inside structs, I can put pointers in it, and that kind of thing. And all of them can fit together, and they can all be accessed under one name, which is the variable name of the struct. So structs are super powerful. When we think about the things that we can do with them, suddenly we have all of this kind of capability to represent something that's more complex than a simple variable. So as opposed to arrays, instead of everything inside having a number, everything inside actually has its own variable name. So it's like chaining a series of variables together. And so that's why the bento box is complete, where it has different types in it. And a struct is going to be the same kind of thing. Taylor is saying they played You're the Voice in Town Hall with a live orchestra and bagpipes when their principal retired. There's nothing more Australian than doing something like that. That's hilarious. But also Nicholas is pointing out Men at Work Down Under. That is an absolute classic as well. So anyone here who's an exchange student, here's some extra education about some of the probably the funnier parts of Australian culture. So this is like at the same level of tackiness as Crocodile Dundee, where it's not a genuine representation of Australian culture, but maybe it's us at our worst. Okay, so structs are our ability to put multiple different types of variables together into one variable, which makes them really useful. So what I've done is I've got an example here of how we might put a struct together to keep track of, for here I'm doing like performers in a group of performers, for example. So you can tell that today my theme for the lecture was all about music and stuff. So I'm jumping from American music to another kind of music here. Why is Dean saying worst? Oh, because I said something about Paul Hogan and Crocodile Dundee, which is a little tacky. Okay, so when we're making structs, we're going to create these, and because they're going to be a variable type that we're going to be using, we're actually going to be declaring these outside of our main. Because what we need to do first is we need to declare there is a new type of variable. And then when we make an instance of that variable, we'll be doing that in our code. But for us to be able to know what the variable is, to be able to use it, we need to be able to say this is a new type of variable outside our code. So it goes kind of along with your hash defines that say here is something that's going to be used across the entire program. And so this is the struct keyword. So the struct keyword is going to give it a name, it's going to have an open and closed curly brackets, it's actually going to have a semicolon at the end. A lot of the time when we've been using curly brackets, we haven't put semicolons on the end. But you note at the top of our files where we have been declaring things like functions that we're going to use later, we use a semicolon at the end of the curly brackets. So the struct is going to be like that. When it's outside of a main function, it's going to have a semicolon at the end of the curly brackets. So we can put multiple things in it. So I'm going to put some of our new data types in here. So I've got a performer. So I'm working on keeping track of performers within a group, for example. And so I have their name, I have a description of them of some kind, and a rank. I just want to put an integer in here. There's not many performance groups that actually have like leaders and different ranks, but this one does. And I know because they yell out their names in order, so like I know that it's gonna be like a kind of a rank thing. So oh yeah, people are noticing the chicken tail. Leon's asking, what does the semicolon do, or is it just how it is? The semicolon signifies that something has finished. So if we were to put a semicolon at the end of any particular line of code, it says that's finished. This one says that this struct has finished declaring. I mean, it's a little bit kind of, as you say, it's kind of just how it is. Because there's other things, if I go back to my code here, there's other things up here that don't have it. So the hash define doesn't have a semicolon. And the include doesn't have a semicolon either. That's because the hash things are slightly different. They're actually telling the compiler to do something before it compiles. But once we get in here, the semicolon says, okay, I'm finished with this thing, which means at this point, I am not going to open curly brackets and say what it is. I'm just going to finish it. And then later on, sorry, got a little bit of lag there. Later on here, where I've got my curly brackets, I don't actually bother with the semicolon. But it's a bit weird because the struct has both the semicolon and the curly brackets. And then the main here has curly brackets and no semicolon. I personally don't know exactly why there's a difference there. I've gotten used to just using them in a particular way. Sometimes I will let my compiler catch me if I'm wrong as well. Okay, so I'm keeping track of my performers here because I want to keep this whole musical theme here. So I've got this one here, and here's a way that I could use this struct. So if I've declared, this struct outside my main, if I want to make one variable that's of the type of this struct, I can do that here. So I can use the keyword struct again and use the name performer, and I'm naming my variable rm. I've quoted rm earlier in the course. If anyone wants to know, rm, also known as Rap Monster, considered the leader of the K-pop group BTS. What we're also looking at here is the dot. So this is something we haven't seen before. If I have the name of the struct itself, and then I want to access one of the fields inside the struct, I can use a dot after the struct's name, so the struct will have its own name, and then I can access the fields inside, and I can get access to these little variables here. Since these things are character arrays, I can't just write information into a character array, but what I can use is a string library function to copy information to the array. So that's why I have string copy into rm name, and rm used to stand for Rap Monster. I think when he was younger and he hadn't figured out that Rap Monster was not going to be a really cool name as he got later into his 20s and he tried to be like, you know, taken seriously and stuff like that. Okay, people have noticed. Okay, Taylor, I did point out that RM doesn't really stand for Rap Monster anymore. So okay, I hope I'm at least there. Zenon is asking if Blackpink is in your area. You know, something interesting. One of the members of Blackpink is from New Zealand. New Zealand is in our area, so Blackpink has always been in our area here in Australia. So we're going to claim. Australians have a really hilarious habit of claiming anyone from New Zealand and claiming any success anyone from New Zealand has as their own. So I'm officially going to do that right now and claim that at least 1/4 of Blackpink is Australian, even though she's from New Zealand, not from Australia. I think it's Rose. Do they call her Rose or Rosé? I'm not even sure. But yeah, I don't know Blackpink that well. I apologize. I actually, people were quoting Blackpink at me last year and I didn't really even know who they were. So I'm just slowly getting better. Yeah. Wait, one's from Melbourne? I didn't know there was another. I thought she was born in New Zealand. Okay, we're going to continue on here. Peter's asking if a struct is just a discount object. If you've seen objects in stuff like Java, or if you've seen classes in things like C++ and stuff like that, this is similar, but it's more lower level. So it's not necessarily going to have all of its own series of functions inside it or anything like that. But it's more like it's just going to organize variables together. Okay, so accessing one field inside the struct is via the dot. So the simplest way is here. If I want to access the integer of their rank, I can take the name of the struct variable. So note now, things are getting slightly more complicated with us declaring variables. To declare a variable that I've custom made as a struct, I use 2 words, not one. I can't just use the word performer here because I've declared it previously as a struct performer, and the struct keyword attached to it allows C to say, okay, this is their particular struct. It is not just an object named performer. So when I create this thing, it's struct performer. This is the type now. So this is going to come up a lot more. We now have types that have multiple parts. So struct something is the whole type, and then rm here is the name of the individual variable. So we need to get that into our heads because it's going to come up again. And also, once we do pointers to structs, then things are also going to get complicated, because the entire type of a variable will be everything before the name, and the name will be the last thing. So rm becomes the variable. And so we've done some string copies with rm, but the simplest way to think about it is rm dot something. So long as the something is one of the names that's inside the struct, we can access one of the fields inside the struct and we can make changes to it. So if we want to, we can do printf here to describe this. I think I have a file somewhere that has all of this stuff as sample code. So I'll try to find that and I'll upload that to today's lecture so that you can go back and run this code if you want to. Another thing that we're going to be doing a lot is putting pointers and structs together. So a lot of the time we're going to aim pointers at structs, because structs are the kinds of things that we don't really need to move around so much. Like once we've created a struct, we leave it in memory where it is. And the things that we move around are pointers to the struct. So we do this so often that if we want to access struct via a pointer, so as I was saying before, the type here, I'm just going to pop out of this so I can highlight stuff. This is the type, yeah? So when we do a pointer, we have the type of the thing it points at, and then the star attached to the name. This is the type, and this says this variable here that's going to be called wrapper is a pointer to a performer struct. So we kind of need to read it in reverse. Wait, your direction, reverse here. A pointer to a performer struct, which is called wrapper, and it's going to be aimed at the address of the previous variable we created, rm. So this might be if we want to give this pointer to a function or something like that. So this means that if we wanted to, if we know pointers, we can say follow the pointer wrapper to the memory location that it aims at, which gives us access to this variable. So following the pointer to that location gives us access to the variable, and then the dot allows us to access one of the fields of the variable, and then we can change it. So if we wanted to change his rank to 100. So the BTS starts recruiting its whole army to be its performers, and they just demote RM to 100th. So that is the way that we could access an individual field in a struct that's at the end of a pointer, right? So this is getting like quite distant in how we're accessing things, but it's quite valid that we might want to do this, right? The way that we do this to make it easier on ourselves is we just use an arrow. So if I have a pointer that points at a struct, which is what this is, because we declared it as a pointer to a struct, we can just use this arrow to say, look, just go to that variable, that struct variable, and look for this field inside it. So we're quite often going to be working with this kind of layout. It's just a shorthand for that, and ironically it takes the same number of characters, but we're going to use this much more often, so it ends up being the way that we use things more. As we get deeper into structs, you will you'll be able to see more of how this works. We have some questions. Oh, string copy questions. So string copy was to copy one string over another. So that was to take, for example, this string. Oops, I can't highlight there. I'm going to go back so that I can highlight. Take this string and copy it over this string, which means it goes to this memory location and it puts these letters into that memory location. So that's what string copy does. Reese is asking, struct performer is making a structure called performer, and then RM is like a member of performer. Making a structure called performer is like me saying this is what an integer is, and then this one here is a single integer in a sense. So this is something we've never done before. This is us saying I'm going to make my own type. So in the same way that we have ints, doubles, chars, pointers, arrays, they're all variable types. This is us making our own variable type. So we would put this outside the main function, and then when we're in our main function, we can create one individual instance of that variable type there. So this definition that we've created was this declaration, sorry. I always get those mixed up because they both start with DE. This allows us to say this is a variable type now, and it has a certain size in memory. So depending on what my max length hash define was, this takes up a certain amount of memory, this takes up a certain amount of memory, this takes up 32 bits. We know integers take up 32 bits. So when I declare a struct performer in the same way here, that if I declared an integer, it would say here's 32 bits of memory, it will store what you need. When I declare struct performer like that, it'll say, okay, here's a big chunk of memory, it's got enough space for those 2 character arrays and that integer that you asked for. So it makes that into a variable that you can use. Dean's answering a bunch of the questions there, so I'm going to let him do that. Steve is asking, doesn't this star wrapper.rank look kind of like wrapper.rank is the pointer? Yes, it does look like that. I think, as Dean's pointing out, that might not actually work in C. What we might have to do is something like this. We might have to guarantee that this gets accessed first, and then after that gets accessed, then we go and look at the rank. So this example was actually just saying knowledge of pointers suggests that we might do this in order to access the rank of the variable at the end of that pointer. But instead we actually use this notation. It's probably why I got that wrong, because I never used that notation because I've gotten too used to this one. Okay. Okay, I'm going to continue because we've got a couple more things that I wanted to say about structs. I think I do. I can't remember how deep we're going into structs right now. So structs are variables. So once we've said this is a struct and we can use it as a variable, even though it's got multiple variables inside it, we can use it as a variable. This means that we can make arrays of structs. That's no big deal. We can also put structs inside other structs. So this is the same thing, only this time I've run out of memes. That we can put anything inside anything, which means we can put things inside themselves. We can't put a struct inside itself that's exactly the same struct. If we put exactly the same struct inside itself, every time we create it, it will try to create another one of itself, which will then try to create another one of itself, which will then try to create another one of itself, etc. So that one's an impossibility, but we can put other structs inside a struct. So structs can contain any other variables that we want, but once we've defined it at the beginning of our code, after that, every time we want to use it, like here, we've declared it as a variable. This thing is just a variable in our code. So this is no different from me saying this is the declaration of a variable. I need to check my syntax highlighting. Obviously it's not automatic in the slides. And then X is a variable I can use from there on. This is a declaration of a variable, and RM is now a variable that I can use from then on for anything else I want. Yeah. So what we get now, the subtlety is that we can create these custom variables ourselves now that are made up of parts of other variables. Okay, and we are dead on 6 p.m. So, just quick wrap up there. Today we expanded what we were learning with characters and strings to be, well, characters into strings, so we can use multiple characters in a string as an array of character variables, and we also had our first introduction into structs. We're going to, I think this is going to be a little difficult because we've got the gap of a week in between, but we'll go into detail about structs in the tutes and labs in week 7, so you'll start to actually use them a little bit. Actually, we might not even go into structs that deep in week 7. I think week 7's tutorial we're going to use all characters and strings, and then we'll get into structs later. But I did want to at least show it to you so that we have an introduction to them, so that when we start using them, you've at least seen the idea of them before. Don't worry, structs are going to be with us for the whole second half of the term, and so we'll get more practice with it as we go along. Okay, I'm going to wrap it up there. Dean's help session is starting. I will do my usual question and answer after the end of the lecture, but I'm just going to switch to the break slide for a bit to say, okay, this is the end of the official lecture, and then I'll answer all your questions afterwards. So, be right back. Alrighty, I'm back. Just shut the door. I won't shut it all the way so that she can get back in if she wants. Okay, so answering a few questions, because there were a few questions. I apologize that I have dropped 2 topics in one lecture on you. Don't worry if the structs are not sitting that well yet. I might actually do a bit of a code demo of structs in week 6 if anyone's interested. But we'll look at them in tutorials in week 7 anyway, so still optional, week 6 stuff. Okay, there were a couple of questions. A simple question there. Leon is asking, what week does the second assignment come out? It'll come out at the end of week 7 and be due at the end of week 10. So the first assignment due at the end of week 6, and then there's a 1-week break where there's no assignment in week 7, and then we will kind of just push all the way through to the end with work. So there'll be all labs, tutes, weekly tests going all the way through week 7 through to week 10. I mean, that's only 4 weeks, so it's not super difficult. And then the exam, I can't remember. I don't think I've got a... Do I have a date for the exam? I think I do have a date for the exam. Usually the exam is going to be very early in the exam period, because when you have a giant subject like this one, because I don't think there's many courses at UNSW that are as big or bigger than 750 students at a time. So when we have the big ones, they will usually be put into the calendars, into the exam timetable early, and then other ones will be pushed back to fit around them, because anything that's going to take up a lot of students, they'll put near the start of the exam period. So there's just a bit of a warning, I guess, in that you're probably going to want to get your study done in StuVac, but you'll know what your exam timetable is when that comes out. We do have some questions. Okay, got some questions coming up now. Yuji is asking, struct performer pointer wrapper equals address rm. Is this equal to struct performer and in brackets pointer wrapper is equal to rm? It is not equal to the same thing. Okay, let me show you that question, because For anyone, that could be quite a complicated question. Oh, you know what I'm going to do? I'm going to see if I have a Structs demo. This is where I would normally look for stuff. I'll look in last terms. Hopefully lecture 10 is the same. No, it's only got word game. So I didn't have a demo file for Structs. I should create one of those at some point. Go back into my current, and we'll create one. You can see that I instinctively go into Camel case all the time, because when I'm typing without thinking about it, it goes into that style. That's a style I learnt originally, and I worked in it for a couple of years when I was working, doing a lot of C++. And so I think it's stuck with me, regardless of whether I should be able to go back and forth between the two standard styles. Okay, some demo code showing Structs. I forgot to put my name on the word game one, didn't I? I did. Yep. Oh, we're in July. Okay. Gonna include our standard bits. Sometimes I need to slow. You can just watch me making typos. It's pretty funny. I guess that's the thing about concentrating for 2 hours straight and then trying to code after that. Need to slow down and actually do this. Okay, so we had the question was, oh, I'm going to need to actually declare this struct if I want to use it. I'm just going to copy paste this, because I think this is something I'll make public later, so might as well have exactly the code that's in the slides. So we had a question. If I've created this already, let's take that creation code here. Line all these up nicely. And then we were looking at making pointers to these. So the question was this. Line looks pretty complex, but when you think about it, if you've seen pointers, this is just a pointer. So this is the type, a pointer to a performance struct, and it's pointing at the address of a variable. So this should work so long as the variable is the right type. Someone's saying I need to define max length. Yes, I do. That's definitely not going to work without it. I saw another question up there that someone was saying, how much space does this thing take up? Does it actually take up the amount of bits for the variables? Yeah. It would actually look at this length here, and add up how many bits each of these takes, and add up those bits there, and then figure out the total size for the struct. It may not be exactly that size. It could be a little bit bigger sometimes, depending on memory architecture and stuff. I'm not going to go into that. Can of worms, big can of worms. That I am not an expert in either, so it's better that I don't say too much about that. I think Dean was hinting at it as well. Okay, so Yuji was asking, is this line, if we were to do something like this, would this be the same thing? And I want to point out that this would not be the same thing. Oh, someone's asking about %s. %s is for string. So %s is going to take this array and be able to print out all of the elements of the array. So it's something that characters can do that integers can't, because characters are very often put together in these collections rather than integers. Okay, so the question here was this. So if we were to look at these brackets. The brackets always mean that whatever's in the brackets gets run first before the other stuff, which means what would happen here is this part of this line of code would run before the rest of it. So one of the issues. Oh, Jeffrey's asking if I'm planning to finish the string demo. Yeah, we're gonna go back to that string demo and add some stuff to that. I don't know how deep we're gonna go because I don't want to stick around forever, but I'll spend another like 20 minutes or so on it. You can already see I'm sliding down in my chair, which means I'm tired. Okay, if we were to do this section of the line first, it's a little bit similar to having it kind of in this order where this line runs, then this line. And the issue with that is that this doesn't mean anything yet because this variable has not been declared, so it can't be a pointer that I'm accessing. So me saying star wrapper implies that I have a pointer called wrapper, and the star is me following that pointer to its memory address and trying to read something from it, or write something to it in this case, which I can't do because this hasn't been declared yet. So I need to have declared it previously as a struct performer pointer. So I can't have this thing in brackets, because if I had this thing in brackets, it's trying to do something that it can't do until after it's declared that it exists. So I'm going to get rid of that. And we come back to this, and then, because the brackets aren't there, this is one component. This is one piece that says the type of the variable that's being created is a pointer to a performer struct. And then here is its name. And so this thing will be created, and while it's being created, it will initially be given this address. So the pointer will be created, and when it gets created, it is aimed at this particular variable. This particular variable. Yeah. So I hope that clarifies that, what you're asking there. Cool. All right. Oh, Taylor and Leon were talking about assignment release date. Because the assignment releases on like the weekend that's kind of in between week 7 and 8, I think that the course outline will be mildly ambiguous about when that releases. The stuff like presenting how to do it in the tutorials and labs, and the live stream which talks about how to get the marks for it, and the breakdown of assessment, and some hints on how to get started, that's all going to be week 8 stuff, because we give you the assignment on the weekend of week 7, and then we give you a few days to digest before we start going in and asking you to actually do anything with it, or have full understanding of it. So the only thing there was use star. Oh, sorry. Some people call it spike, this one, when they're looking for just like a quick way to talk about it. The arrow. Use the arrow to access a field of a struct through a pointer. Okay, I'll upload this later so you can play around with it if you want. Okay, let's go back to our word game. So, unless there's other questions, there might be other questions. So you just saying, so the star links with performer here. Yeah. So this is one of the interesting things, even though the star here is next to this word, this is the type. Yeah, and so anytime we declare a pointer, so an integer pointer or anything, it has a star, but it actually has a space between each of its components, and then it's just attached here. You can actually even do it like that, and it still works. But this is the standard way of doing it. The reason why this is the standard way of doing it, because if we were to declare multiple variables on one line, this is also why declaring multiple variables on one line is a risky proposition. So if I do int I, let's just not give it a value. This declaration is going to declare 3 integers. This declaration, so if we were to attach the star to the type, Now, this is interesting, right? Because we're starting to think about, like, what does this actually mean? So, what are I, J, and K now? So, I is a int pointer, J is, and K is. Are they integer pointers because the type was declared there as integer pointers, or are they just integers? The answer to this is they're actually integers. So, if we attach the star to the type there, it makes it look like all these three are going to be the same type, but it's not actually. So that's why we attach it here to say that if we did it like this, then it makes more sense to us. We can see that this one's a pointer and these aren't, because they didn't have stars on them. I don't even know if this works, because I don't like doing it like this, but I think if you do it like this, then they'll all be pointers. That's the reason why the star is on the right hand side attached to this word, not that one, so that if someone gets into this situation, they're not going to confuse themselves as to what types they're creating. I don't like the idea of declaring more than one type in one line. I think that's kind of messy and dangerous, and you can get confused as to exactly what things are, as we're probably getting confused here on this line as to what things are. So I much prefer, if you're going to do something like this, you go, if you want 3 pointers, look, it's not going to cost you that much to put them on their own lines, you know? And let's say I genuinely wanted that one to be an integer and not a pointer, then it's really clear when I'm reading it which ones are pointers and which ones aren't, if I keep them on separate lines. Yeah, wrapper is a pointer. Zenon's asking if wrapper isn't a pointer, but it is definitely a pointer because it's got a star on it. So I've declared a variable here, and a variable with a star in it says it is a pointer to this type of variable. So if there's a star anywhere in the declaration, you know it's a declaration of a new variable because it has a name that hasn't existed anywhere before. So if we're creating a new variable, it gets a new name that hasn't existed before. Wrapper, it is definitely a pointer to a struct because it has the pointer symbol. This is like saying pointer here, and so if you see the star, it means there's definitely a pointer involved. So yes, this is the type of this variable, so it is a pointer to this particular struct. So it will be able to access a struct of that kind if you can point it at the address of one of those, which is there. Okay, I'm going to get rid of that because that's going to muddy the waters for the specific struct demonstration there. Okay, let's go back to our word game, as long as everyone's keeping up at this point with that. Don't worry too much if things aren't entirely working for you. I've only just introduced it to you, so you've seen it maybe half an hour ago, so it's not necessarily something that you have to fully understand yet. What I would want to do is to basically put a bit more time and effort into it, get you a bit more practice in it before I'm going to say you need to understand this. You know, I'm never in a situation where I think that someone, especially near the end of a 2-hour lecture, is going to be able to take a new concept and be fully up to speed with it. So it's totally fine if we need more practice with this before we have a full understanding. Okay, so here in our word game, I'm going to remind you of where we're up to. We were able to read in a line, and then we were able to read in a series of individual characters. And for each individual character we read in, we could find out how many times that character appeared in the line. So we've got this nice function here called test_char, which is going to test how many times a character appears in the line. I don't like that name already. See ya, Echoic. I don't like that name already because it's not a test. It's counting how many times are there. So I think I'm going to rename that. So I'm going to select this and press Control H. Control H is going to do a replace, and I know that it being test_char, it's pretty safe for me to replace this because I'm not replacing a simple word, I'm replacing definitely a function name. So I'm gonna replace that with count char and go replace all. It's told me it's replaced 3 occurrences, which is good because I know that there's one here, and one where it was used. So count char equals char count. That actually makes sense. You know, it's a little scary because I'm just using the same words, but it sort of makes sense. This is an action and this is the result of that action. So count char is going to count how many times the input character appears in the line, which means that we could definitely use this if we read in another line and we could see how many times something matched in the other. What I might want to do is put a little bit of time into deciding how this is going to work. So take in a second line of input. Oops, auto-completed by accident. Then I'm going to loop through the second line, add up how many times letters in the second line, is that my spec? Output how many letters from the second string appear in the first. Yep. Add up how many times letters in the second line appear somewhere in the first line. So we're not actually looking to count how many times they appear in the first line, but we're counting how many letters appear in the first line. So I think I can write this code. So what I'm going to do first is take in my second line of input. Line 2. If anyone can think of a better variable name than this, I'm open to options, because I don't like line and line 2. I find that a little bit scary. But I can't think of another name that's going to give it more meaning. So I could call it test line or something, but it's not really, that doesn't actually give it more meaning. So I'm going to stick with line 2 for the moment. And I'm going to say it is similarly capable of holding more stuff. String and string 2. Thank you, Michael. Your opinion has been noted. Yes, that signifies that they're strings, but it doesn't differentiate them from each other that well. Oh, someone's come to say hi. I can't see her face right now because my webcam's not turned that far, unless I turn it. Hello, what are you doing? She's just come to say hello. She's pretty chill at this time of the evening because she's had her dinner. Okay, so we've got a second line there, and then we're going to take that second line, and it's going to be really similar to what we did with the previous fgets. But in this time we're writing into line 2, but the amount of stuff we're reading in is the same. And where we're reading it in from, standard input, is the same. What we haven't done here that we might want to do is actually talk to the user a bit, because it's a bit confronting when you run a program and it's just empty. So like when we ran this before, where is it? Oh, I did a lot of stuff in between, didn't I? Okay, I run this, it just drops to the next line and sits there with a cursor. Which is fine if we know exactly what the program's going to do before we want to run it. But sometimes I think I want to give it more information than that. So I'm just going to Control D out of that. So what I might do is send some information to the user. Weiwei is saying, will the line and lines read the new line? They will. Yeah. So that is a problem. That's a problem that we're going to get to once we start testing how this works. But what I'm going to do is give some information to my user. I might just do that. Alright, so this means the user is going to be typing things on the same line that this printf happened because I didn't put a new line there. Having said that, yes, as Weiwei is saying, we are if we call fgets, we're going to be picking up the new line on the end of that, as we've seen before when we tested fgets. We'll deal with that in a second. So for the moment, we're going to read through, we're going to read in these two lines. Then we're going to loop through the second line and add up how many times the letters in the second line appear in the first line. So loop through the second line. I like to break things down, you know. So what I can do is I can construct a loop first. Are we using I anywhere else? I am not. And I'm going to say I is looping through the second line, so it's line 2. Here's the mistake that I made in the lecture. So long as line 2 I is not equal to the null terminator, and it's also I has not gone over the max line length, we know we're still inside the array. I is going to plus plus because it's going to move through the array. So I know this is going to loop through, and then inside that loop, I'm going to select both of these and tab them in. Inside the loop, this is what I want to do inside. So I want to add up how many times letters in the second line appear somewhere in the first line. So I have something that tells me how many times a letter appears in the other line. I don't need to know how many times. At the moment, I just need to know if it does or doesn't appear in the other line. So if I want to add up how many times letters in the second line appear in the first line, I'm looking at a number that's going to accumulate based on how many times these letters have matched. So I'm going to need a number outside the loop if I want it to accumulate. Int, this is a match count, I would say. It's going to start off as 0, and then it's going to go up the more times we see letters from the second line appearing in the first line. Ooh, that's an interesting one. Where we're saying if we put a condition like line 2 is not equal to new line, maybe we wouldn't count the new line. Maybe we would stop before the new line. So that's an option. That might... Yeah, okay. Let me just... Because what we're looking at here is this situation. A, B, C. New line at the end of input. And then other stuff here. So there's a new line and then there's a null terminator. So if we stopped on the new line instead of the null terminator, we could potentially get ourselves into a situation where we go, all right, this is our valid stuff. This is the thing we're checking for. And if we check for this, assuming that we're always going to get new line in these inputs, we could just reject the new line there. This is actually really cool, and I love the fact that you came up with this idea now, because it's different from what I did in the slides, and so I think it'll be interesting for us to do. And that way, if you go back and look at the slides, you can look at a different way I did this, where I come back afterwards and I strip this out by replacing it with a null terminator. Because if we genuinely didn't want it there, maybe we want to edit the whole string rather than just stopping here. However, that's all we needed to do with these things, so maybe that's okay. Alright, so line 2 is going to go through there, and it's going to go up until the new line. So the new line is never going to be part of the characters that are checked. And so we can then add up how many times letters in the second line appear somewhere in the first line by having this match count here, and we can say if there's a match, so if, what's it called, count char of that character in the other line. So we're going to see how many times we can find characters from line 2 in line 1. So The first line is the one we're checking against, and the character we're checking against is the current one we're looking at, because we're going through the characters in line 2. Ooh, line 2. And if this gives us a result... I've got my brackets entirely wrong here. No. These two are the inputs to count char. Count char has these brackets, and then the brackets of the if statement are there. I'm going to put some space in here so I can see this. Yeah, okay. This is a function call. Function call is going to be 0 or another number. If it's another number, it means there was at least one match. So if there was at least one match, then the match count is going to go up. So this isn't using the number of matches that it found per letter. It's just saying how many times letters in the second line appear somewhere in the first line. So if they appear more than once, we're still counting it as 1. So this is going to accumulate how many times it saw things. And then when it's finished, here I can printf. I don't know why I'm writing comments here. Printf. I found characters from the second line this many times in the first line. I'm a little bit over 80 there. I'm just going to leave it. Oh no, I'm not going to leave it because I need to put the variable in there as well. Now I'm far enough above 80 that people are going to get confused. Alright, do my bracketing thing there. Okay. If we put condition like new line, maybe we don't count new lines. Yeah. If we don't exceed max line length, we will have new line before the whatchamacallit, the null terminator. I think you're right there. Wait. I think that the only situation, so the situation that we could have a problem with is if we hit max line length. But if we hit max line length, then we're just reading to the end. If we're not hitting max line length, we're definitely going to find one of these before we would find the null terminator. So I think that this is probably going to work. You can see how I'm being cagey with that. I'm not saying it's definitely going to work because I'm not sure. I would still do a whole lot of testing with this. I would potentially drop this down to like a low number and then test pushing it to its limits and see whether we can break it or not. But I think that you are correct. I think you're logically correct that there's no way that we won't have a /n. There's no way that we won't have a new line if everything here is working. And even if we go off the max line length, it doesn't matter if we don't see the new line because we'll see max line length. So if someone types in 1500 characters instead of 1024, so the new line doesn't get read, it's off the end of the things, we'll still just go to the end of this. If it's anything shorter than 1024, the new line will appear before the null terminator will appear. Oh, unless okay. One example that it could be different is it's exactly 1023 and then there's a new line. So the new line is the only character that gets cut off, but makes sure that there's a null terminator at the end. We can test this and make sure, but I think your logic is pretty sound though. And Michael's saying the same thing. I think it's pretty sound, but we can test for this. We can, like, instead of like we could theoretically talk about it, but I think what's best is like, okay, what does it actually do? So we'll find out in a second. Let's just see if this works the way we want it to work with this output here. And this bit, we are no longer going to, oops, grabbing it the wrong way. We're no longer going to use any of this because this was just for a single character at a time. So let's see if this works with our 2 lines here. Going to compile this. I'm just going to type in the compile again. I don't know how far away my compile command is. Okay, let's run word game. Please enter 1 line of text. What is it? Gina works the diner all day. I don't know how many people we've still got in the chat who know the song. This is the next line of the song. I should have looked up the lyrics before coming to the lecture, but I think I was like, maybe it's better to just be natural to get the lyrics wrong the right way. What's the next thing? What is it like? It's something like Tommy Whispers "Baby, It's Okay" or something like that. That's the kind of thing where I need someone to sing the song before I'm going to be able to figure it out. Okay. Maybe. I should have done this more simply so we could test whether this was actually working or not. Okay, I found characters from the second line 20 times in the first line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 25, 26, 27. Okay, so 20 out of the 27 characters appear in the first line. That sort of makes sense. So T does not appear in the first line. O does, so that's 1. M does not. Y does, so that's 2. Space does, that's 3. W does, that's 4. H does not. I does, that's 5. S does, that's 6. P does not. E does, that's 7. R does, that's 8. S does, I should have done this with a shorter example. S does, definitely we've seen that before. That's 9. Space does, that's 10. B does not. A does, that's 11. B doesn't still. Y does, that's 12. Space does, that's 13. I does, that's 14. T does, 15. Apostrophe does not. S does, 16. Space does, 17. O does, 18. K does not. New line does, I think that's 19. Did I get something wrong? It says it found 19 thing. It says it found 20, but I counted 19 by hand. However, oh, K does. Oh yeah, K does. So it's 20. All right. Thank you, SK. So it's highly likely to be correct. We would probably want to do more testing to be sure of whether this thing is correct, but it's spitting out examples that are reasonably correct. Let's do something simpler. I'm just going to do the next line of the song. It's okay. So this is really simple. And next line of text, I can say just I should get 1. Okay. Me getting 1 is good because it means it's not matching the new lines. Next line of the song is also it's okay. I think they repeat that. And let's say we are here. So none of these should match except there are 2 spaces. So I'm looking for 2 matches here, I expect. 2 times. All right. We're getting more information that says this thing is reasonably likely to be working. And as Michael's saying there, stopping at new line also stopped it from counting the null terminator. Yeah, totally. Because if you stop before this new line here, you're never going to look at the null terminator. This is assuming that the new line definitely appears in every possible string that we could create. We haven't verified that, but I accept Weiwei's logic here that I think that they are correct. But, you know, I'm never going to say someone's correct until I've seen the code working. Because I've looked at people's code and going, yeah, that will totally work, and then we run it and it doesn't run. So there's always a thing where we're going to want to look for certain to see whether things are working or not. Okay. This means we've actually solved the majority of the problem, but what I want to do is I want to test this new line thing because I've got a little bit of uncertainty here, and I think we've all got a little bit of uncertainty. So last thing I want to do before we wrap up today is to test this new line. And I'm going to be able to test this if I do something like this. Let's drop it to 10 characters. Actually, I'm going to drop it even further. Let's drop it to 5 characters. And now we'll be able to make strings that are really close to this limit because we didn't write fgets. So we don't know what fgets is going to do around that limit. Is it always reserving the final letter of these lines for a null terminator? Or is it going to be able to create something that has no null terminator if we type in too many things? And is our code here going to be okay if it hits max line length? Is it going to hit a null terminator or not? So let us test these things. Let's think about what kind of things we can do with length 5 to test these. So compile that again. My maximum length should be 5 now. So let's do a quick test of that. Hello there. Oh. Hello there. Did not like this. Index 5 out of bounds for type character 5 using illegal array index. Yes. Huh. Okay. So now we are seeing some of the ramifications of what's going on here. I think I'm going to have to show you something there. So I said hello there. I'm going to put a space in here so we remember there's a space. And a new line. The first fgets can take in 5 characters. 1, 2, 3, 4, 5. The second fgets then takes in 5 characters. 1, 2, 3, 4, 5. There are more characters, but it never uses them, and then it starts looping. So I think that maybe the first array was here, and then the second array was here. But let's see what the actual error was. Line 2i is not equal to new line, and I is less than max line length. Illegal array index 5. Oh, I got it. Right. We made a weird assumption here. If I is equal to the max line length, then we cannot access something inside the array. So if this goes off the end, I should not be checking a character inside the array if this has not been, if it's not possible to do that, if I has gotten too high. So I actually had these in the wrong order. What I needed to do was this. Because the way that a check inside a while loop is going to work is it will check the first thing first, and if this fails, it'll never check the second. So what I can do is I can do my safety measure here that says, if I've gone outside the bounds of the array, don't start looking for a new line in the bounds of the array. But what I'm also going to do, because this was something that, who was saying this? Michael was saying this. Let's do some printfs to see the string entries, and I think that's a really good idea. So %s line, and we'll do this one here. We could also do fputs. Actually, let's do fputs. Fputs line standard out. Just want to use the new things. I mean, it's functionally identical. Line 2, standard out. Okay, so now we will see what we're reading in. And the subtlety we want to look at here is, do these things have new lines or not? Maybe they don't have new lines. And we'll see how many characters they actually got. Yeah, Jeffrey, it's a bit of a subtlety here, this idea that since the while loop checks this stuff in order, if this one was going to fail, this one causes a much worse issue. Because if I have this I and it's just here gone up to 5, I want this thing to stop this thing from ever being able to check it. So I want the dangerous one to be checked first, and then the sort of normal one to be checked afterwards. But let's have a look at what's happening here, because I think there's a lot of stuff going on there. Oh, great, some information. This actually was showing us what the line and line 2 were. This is the beauty of using DCC. It actually shows you the variables when execution finishes. So what it's actually saying is my hello there. It was not taking 5 characters. It was not what I thought here. Let us erase this. What it was doing was taking 4 characters and then putting the null terminator in. It was guaranteeing that no matter what we did, there'd be a null terminator. And then 4 characters was going in the other one. Which means that if we go over, we're not going to see a new line. However, the fix that we've just put in here might already fix that problem. But let's run this again with our fputs showing what we've got and see whether this still works. Okay, so I'm going to compile that again. This was like me kind of fixing more than one problem at a time, so it's a little bit potentially dangerous. So Michael's saying Weiwei was right here in that you said if we put ABCD into the line, the max length is 3, we will only have a string like AB and then the null terminator, so we won't get the new line. Yeah, so Weiwei, I think you're correct there, where the the fgets is making sure that no matter what happens, it will always give you a valid null terminated string, because it's much more dangerous for it to give you a string that wasn't terminated properly than for it to give you a string that that was just a bit shorter. What we are learning, however, we're learning here that before, so earlier, you know how we had rock solid logic, you know, we were guaranteed that we were always going to see a new line. Now we're seeing that we're not, because what's happening is that the computer is buffering our content. So it's saying, if you're going to type in all of this stuff and it's bigger than what these fgets can take, then these two fgets things are going to run on the same content, and they're going to take us however much of it they can take, and then the rest of it will still be waiting there to be input into the next thing. I mean, you notice that when I typed it in, hello there, it never even got to the point where it told me to enter the second line of text, but it had definitely done it because we'd already gone past it, but the terminal had just not caught up, I think, and it had definitely read it in. So it had read it in even before the terminal had gotten to the point of saying what was happening. So interesting kind of differences of like the line by line thing. It's not a guarantee, because it looks like the program had gone past this line, but as we see up here, it had never been printed out. There's a lot of interesting little subtleties going on there. Let's try this again. Okay, so we're flagrantly going over the line limit here, the size limit, and we're going to have a look at what actually comes in. Okay, so that's the line, the first bit, and then it says please enter the second line of text, and we're getting this as the second line of text. And note, the important thing here is this has a new line on the end. We can tell because we come down to the next line. This does definitely not have a new line on the end because the next character is just the next output. This one here, these 4 characters also do not have a new line, and it goes on. And then it says it found this many characters in the other line. It found 1 character in the other line, which I'm going to assume is the H. Which means that it is not finding the null terminator, and it's not saying that the null terminator matches in both. And I think the reason why it's not saying the null terminator matches is we were careful here to make sure this. Although this is now dangerous in the same way that this was dangerous before. What if there's no null terminator? I don't know if that's necessarily going to happen, but what if this array that I was given wasn't formed properly. It's just an array of characters. It's not a proper null terminated string. I should check this first so that I don't accidentally try to read something off the end of the array. So I'm just going to Control X that, cut and paste, put my and in there. And I'm just going to ensure that this thing is now safer than it was before. Alright, see you later, Andrew. And see you, Taylor. Okay, so a couple of things that we've figured out here. This we can't guarantee. There will potentially be situations where we will have a null terminator instead of the new line, and that's specifically in times where the typing goes over the end of the length limit. So if we go past the length limit, we can still guarantee we'll get a null terminator, but we can't guarantee that we will actually get a new line. There's actually a decent chance that we won't get a new line if it goes over. So this test does not necessarily leave us at the end of the word. So what we might want to do here, I'll show you a trick that we can do here to make this like a double guarantee. So this is going to try to remove the new line, which is good. We want to, if we see the new line, we want to stop. We can do this. This and line 2i is not equal to the null terminator. I think this will work. So what this says is, if we reach the end of the line, we're going to stop. If we reach a new line, we're also going to stop. So this is for the case if it's well formed and it's less than the line length. So if it's shorter than the line length, then the person gets to press enter and enter goes in. Otherwise, if they went over the line length, stop if you see the null terminator. I mean, it's kind of like if you go over the line length, you're going to kind of hit that one as well. But this will be one shorter than it. I'm trying to think of a situation where we actually need this. I'm not 100% sure on that. Yeah, I think you're right there, Michael. We could also check max line length is I is less than -1. But again, the issue is, what if we get an incorrectly formed string? So this is if we have a correctly formed string. This is if we have a string ending in the new line so that we can ignore the new line. And this is if we have an incorrectly formed string that fills up the entire array. So that's if we weren't using fgets and we were using something else. I think this will work. Let me compile this, because usually putting 3 things between ands will, I think theoretically that causes a problem, but I'm not sure. Nope, I think it's just going to do them in order. These 3. And if any of them fail, then it's not going to run the while loop. So it checks this one, then this one, then this one, and if they're all true, then the while loop will run. Okay. Try that again with the same silliness. And it's still able to do it. Let's try it with a different amount of silliness. Exactly that. Oh. Okay. Michael, I've been using like 5 and if statements in some of my labs. It's okay. One thing that we might do for that is something like this. I don't know whether I'd put this above or below. Something like that. And that way you can read each condition on its own line. I have no idea where these brackets should be. I'm trying to think of like where I would put them style-wise. Maybe I would actually leave them there. So this allows you to go, okay, this and this and this. And it's a little bit easier to read. so it doesn't stretch too far along, especially if you've got 5 of them. Okay, so this kind of thing will get us to this point, but now we've encountered another issue. So if I go over the end of the maximum amount of text and I press enter, then the second line of text was empty with a new line in it. That's not too bad because it's got a new line and then a null terminator, so this while loop will just never run, and it'll correctly say that it found 0 characters from the second line in the first line, because the second line had 0 characters. So, yes, this sort of works, but again, we're seeing this issue that if you go over the intended maximum length of the line, everything goes weird. Like, nothing is working well at the moment in this case. So, interesting. Lots of food for thought. And so I should probably wrap it up there. But I think, Weiwei, you had a question. It looks like you retracted it, which means maybe you figured out what was going on there. Okay, great, awesome. I'm gonna wrap it up there because we've got a whole hour over time. But I think we explored a lot of interesting stuff here. So hopefully on the video, if people come back and watch this, they'll see a lot of the rationale behind all of the fiddly stuff we ended up with here. I might put some comments in this as well before I upload it. But I will upload this as part of today's lecture and stuff like that, as well as the Structs demo for people to see, so that people can play around with this code when you're studying later. You can check it out. Zenon's asking if we will go deeper into Structs next week. Next week being flexibility week, it's like a break week. We won't necessarily be doing anything new with Structs, but what I will do is I will do another demo that has Structs in it. So more than this. This isn't very much code. Right, I'm going to do more than that and use them so that you can see them in use. That's optional, though, because it's not... it's during week 6, but I will try to do something anyway, just so that you can see it. And after that, we'll definitely go deeper into Structs. This is definitely not the last time that we're going to see Structs. We're going to be using them heaps. So even if you don't get them now, you'll get another chance to pick up on them. All right, I'm going to head off. Thank you all for hanging out. I think that we actually delved into some really interesting stuff at the end there. So I'm glad that you hung out and we had a poke at this. Okay, see you later all.